Alright, here we have a video discussing the evaluation of functions. Sometimes we'll also write a function. Okay. The reason why I am differentiating between the evaluating and writing is that when we say evaluate, we usually will get a numerical result, but sometimes we will not. For example, if we have, for example, like number problem 5 and 6, here we are asked to evaluate. Well, evaluate is not quite a right terminology, because the input for number 5 is c plus 7. There obviously is a variable c, or literal part of the input c. So chances are we may not get solely a numerical result. Okay, for that reason, I'm using the terminology of writing function. Okay. All right, I know sometimes writing function means you need to create your own function. That's not really what I'm talking about in this particular video. All right, okay, let's begin. So you are given 4 functions: f of x, g of x, k of x, and m of x. And before I begin discussing each problem, I want to clarify some terminologies and the way I speak about a function. For example, that f of x is equal to 4x plus 9. I use the word of, f of x. Number 2 problem is g with input -4. I'm going to call that g of -4. All right, I just want you to be familiar with the terminology that I'll be using throughout this video, and probably some more videos that is going to be uploaded later. Also, terminology about input. For example, number 1, the input of that f is -12, and at times I'm going to call that -12 as an argument. So number 1, the argument is -12. And let's go down, like number 5, the argument of that f is c plus 7. Number 6, the argument is 4a, and so forth. All right? Okay, so let's begin. Number 1 is dealing with f of -12, and basically what you are asked to do here is substitute x of the f with a -12. So since f of x is defined as 4x plus 9, we will just simply substitute this x with this half. So it'll be 4 times -12 plus 9. All right, and you do your computation. 4 and the half cancel out, so that'll give us -2 plus 9. So the answer should be +7. All right, so that should be fairly straightforward. Okay, and let's go number 2, g. G is 2x squared plus 7x minus 1. That is what we call a quadratic function because of the square part of the function. Okay, so let's do this. So that should be 2x squared. X is a -4. Be careful, you gotta have the parentheses. If you don't have the parentheses, that is incorrect. 7 times -4 minus 1. Okay, that's a straight substitution. And let's just do our computation. 2 times, that's +16. That's -28 minus 1. So 32 minus 28 minus 1. So that should give us 4 minus 1. So that should just be 3. All right. So that's our answer here. Sorry, I forgot to circle the answer for number 1. Okay, number 3, dealing with the k function. K, as you can see, is a little complicated. And k is what we call just generic polynomial, sometimes polynomial of degree 3, sometimes cubic function. Okay, all right, so let's just be careful. So that is going to be, I have a parenthesis -x squared, so negative of -5 cubed. All right, be careful because we have this part, that's where the negative 5 goes. Okay, continue, subtract negative 5 squared minus negative 5 plus 14. Oh, a whole bunch of negatives. Okay. All right, let's do our negative of negative 5 is positive 5 cubed. Subtract negative 5 squared is positive 25. And the reason why I have that negative sign in front of 25 is strictly from here. And 25 is all of that. Okay. All right, continuing. Subtract negative 5 is positive. Change color. Positive 5, positive 14. All right. Then let's clean this up. 5 cubed is 125. Subtract 25 plus 5 plus 14. That should be 100 plus 5 plus 14. So that's 105 plus 14, and our answer should be 119. Right? Okay. And number 4 deals with m. M is what we call rational function, 4x minus 5 over x minus 6. So that should, let's just go ahead and substitute. 4 times 3 minus 5 in the numerator, x minus 6, so 3 minus 6. So that should be a pretty straightforward computation here. 12 minus 5 is 7. 3 minus 6 is negative 3, and that's it. Negative 7/3. You can leave your answer like this, or some people may prefer to write as negative of 7/3. Doesn't matter. They're all same. Okay. All right. Okay, number 5. F of c plus 7. Okay, what was f again? F was 4x minus 4x plus 9. So x will be replaced by c plus 7. So this is going to be 4 times c plus 7 plus 9. Again, that's because the f function was defined as 4x plus 7, and the argument here was c plus 7. Okay, so only work that remains is just distribute 4, so 4c plus 28, because 4 times 7 plus 9, so that should be 4c plus 37, and that should be it. Okay, again, this is the type of problem where we don't get all numerical result because of the c. Okay, number 6, g of 4a. What was g again? Go up. G was a quadratic function. Okay, so 2x squared plus 7x minus 1. So that is going to be 2 times 4a squared plus 7 times 4a minus 1. And as you can see, we will have a as part of our solution at the end. All right, let's clean this up. 2 times 16a squared, because 4a squared, you will need to square the 4 and square the 2. All right, plus 28a minus 1. And only thing left for us to do is just multiply 2 and 16 and get 32a squared plus 28a minus 1. That should be it for this problem number 6. Okay, number 7. And kind of similar to number 5, because our argument now, well, is 2 term a plus h, but obviously both are letters. Okay, now m was, I kind of need to go back to, well, my function was 4x minus 5 over x minus 6. So let me just kind of rewrite that out. So again, m was 4x minus 5 over x minus 6. All right, let me just verify if I wrote that correctly, because if I write wrong function, I get a wrong result. Okay, All right, so all we have to do is for m of a plus h, that will be 4 times a plus h minus 5. Don't forget the minus 5 is still there. And a plus h minus 6. And I don't need a parenthesis in the denominator, but I just put it there so you know where that came from. Okay? All right, and all we really have here is to distribute the 4 in the numerator. So 4a plus 4h minus 5. And the denominator a plus h minus 6. And that's really all we can do. There's nothing more we can do here. Right, before I move on, one big word of caution. When you see this 4 parentheses a plus h minus 5 over parentheses a plus h minus 6, you probably were tempted to maybe cancel like this. This is very wrong. Do not do this. Okay? You cannot do this because the top and bottom are not factored. You can always cancel when you have a factor form. All right? So you cannot cancel, and same reason you cannot cancel here. That's also very wrong. Oops. I got an orange color. Very wrong. Don't do this. No cancellation. All right? Okay, last problem, g of m of 0. This is the first time we see where two functions are kind of meshed in together. Okay? All right, we got to go one at a time. First, we got to do m of 0. Okay, so what is that? M of 0, I wrote down what the m function was. So 4x minus 5 over x minus 6. So if x was replaced by 0, I would have negative 5 over negative 6, which is just positive 5, 6. So this problem actually comes down to nothing more than, sorry, let me just draw a line, nothing more than g of 5, 6. Because we just found out m of 0 is 5, 6. All right, so g was a quadratic function, so that is 2 times 5, 6 squared, 2x squared, plus 7 times 5, 6, 7x, minus 1. Okay, remember g function was 2x squared plus 7x minus 1. So all we have left is a whole bunch of kind of ugly fraction work. All right, so let's finish that up. So that is 2 times 25 over 36, because 5 squared over 6 squared, and plus 35 over 6, 7 times 5, subtract 1. All right, and let me reduce the fraction a little bit. 2 and 36 can be reduced as 18. Okay, so this will have a one big fraction with denominator 18, and that will give me 25 plus 35 over 6. 6 times 3 is 18, so 35 times 3 is 105, and 1 is of course 18 over 18. All right, okay, so what we have there is going to be positive 112 over 18. Now each is even, therefore we can reduce this as 56 over 9. 56, a little bit small, sorry, let me, I think I have more space at the bottom. Yeah, good. So that is equal to 56 over 9. All right, and that's it. You cannot reduce that anymore. If you want to, you can switch that into a mixed fraction, but that's good enough here. All right, that's it for this video.